Yes, so I had this for my dad for a while. I made him this switch box so you can connect 6 amplifiers and then one set of stereo speakers. So, and it doesn't work, so I have already tested it. It's the power supply. So, but before testing it, I made the mistake of starting to designing it with a microcontroller. So yeah, so when I plug it in, it's not doing very much. So I'll just connect everything, like set up some audio here, right there, and just beef it up all the way. Connect some audio and then to the box. Yeah, there you see it switching. And I also can hear like a faint hum here, so anyway, so let's open it, see what's wrong, what's going on. Make a quick video to show you what's wrong with this box. And actually nothing is wrong with the box, it's the power supply. So, okay, so let's see here, power to the people. And you can't even see it blinking this time. So it's like just lighting faintly. This is the light. This is the pulse. It's actually, this is a 555 timer, which creates like a clock. So, and then we have a counter that counts from 0 to 7 or something to scan all the ports here. So I have made many videos of this, so you can watch it. So, and you see 2.5 volts. It's very pretty bad. Yeah, so let's connect the external power supply. You can see here 5 volts, bang, and there you see the clock is ticking, so everything is working. So that's great. I was designing this with an Atmega 328 microcontroller, just to replace all the digital logics. We have 2 registers. We have one for storing the actual current selected speaker or amplifier, and we have another register which is a temporary register, just stores the last port where the there has been audio. So yeah, so that's cool. So just to show you that it works. So where are the plugs? Here, so put some audio in here now. If everything's plug it in. There, now. So let's see. So if I go here, by the way, these are completely isolated from each other. I'm using transformers actually between them. So to speak to actually. Okay, so we're moving on. So you see it finds the signal. And if you look in my earlier videos, you will see that it also not only finds a signal, but it will also stay on a channel if it's there. So yeah, so that's an easy fix. I'll just buy a new one. So, but while you're here, I can show you again. Maybe you are interested. Just turn it off. I made this modular. So this was you can ask yourself, why do you do this in 70s style digital logic, right? You have like a comparator, and then inverters, and registers, multiplexers. What you actually need even today would be just like a microcontroller, so that's what I've drawn on the screen. So that's the idea, just scrap all of the other things and keep the sensor. So this is LM339 sensor, so that detects the peaks and stores as a latch, because digital logics, they want latching. So, and this is the multiplexer, and the counter is connected here. So it scans through all the input channels, so which is the right channel on every amplifier. So yeah, so I can show you that. It's a long time, you know. It's been a year since I made this board. So let's see, I can get it out. Like this. This is the control board, right? So you can adjust the sensitivity. So when I was at my dad's, he said that it has a tendency to switch when it's not supposed to. So we just increased these the threshold, so it desensitized it. So it has to crank up the volume a bit more. This current register I was talking about stores the counter value such that you get the channel you want to listen to, and then the appropriate relays will turn on then. So yeah, so here it is. Here are the transformers. These are only used for sensing and to isolate all the amplifiers, because when you're sensing something, you want common ground. You can't have common ground on separate amplifier systems, right? They can have their own ground. They can have floating ground. You can have you can get lots of problems there. It might not be ground even. So yeah. So watch all my other videos if you're interested in the design of this. So, and it works fairly well, so as you can see in another video. And the problem he had was that he said that it was only one channel he could hear audio. So now when I test it, it's both channels. So what I think happened was that since it was like 3 volts when I measured last time, now it was 2.5 actually. Only one of the relays turns on and the other one just stays there for some reason. So yeah, so therefore you only get one channel. So yeah, so if I can show you how I test that. It's a bit noisy though, but let's see, let's get some power on it. There, 5 volts. It's you can see it over there. It's draws about 172 milliamps. That's actually a bit much, but you know, relays, they are a bit hungry. So now you can see it changes channel, and then if I take the probes, let's say I want to check this one. This is the output. You see that there's no connection until here, and then nothing there. So if I move this one over here, there, yeah, so yeah, I need to fix my phone or something. So but now we can see there's no connection from here to output, but now it's here. So, and then what I checked is that you have connection on all of these, right? But nothing in cross. So I went all over this. So check that everything is okay. So everything is okay. So oops, there it switched really fast. So So yeah, so please see all my other videos. This will be very easy fix. Just find a proper power supply. Actually, I will find a good one. This one's sucks really bad. It's cost like not even $10, if that's translated properly. So yeah, it's meant for charging a phone, but I'm using it for 24 hours a day use, so maybe that's the reason. Yeah, anyway, thanks for watching. See you soon.